Okay, now that we know the basics of first, second derivatives, let's try an AP style problem. Remember, we will have to go back and forth between first and second derivatives and the original function, so a knowledge of antiderivatives will be necessary. Here's our problem. A particle is moving with a velocity of square root of x minus 6x squared along some curve. If the particle started at the coordinate 0, 7, what is the position of the particle at x equals 5? Well, if we look at our problem, we see that we are given velocity, which is what is associated with the first derivative, or f prime of x. Yet this question is asking for position. Position is described by the original function, f of x. So if we're given the first derivative and we need the original function, we have to take the antiderivative. So in order to do that, we rewrite the square root of x as x to the 1/2 minus 6x squared. In order to take this antiderivative, we do our antiderivative technique, add 1 to the exponent, so it's x to the 3/2, divide by your new exponent, 3/2, get the fraction out of the denominator by multiplying by its reciprocal. So we have 2/3 x to the 3/2 minus 6x cubed over 3, which is equal to 2/3 x to the 3/2 minus 2x cubed, which is equal to our first derivative. Now it's great that we have our first derivative, but we need to figure out how to get the actual position. Well, we're given an x value, so we just plug our x value into our first derivative. So it's 2/3 times 5 to the 3/2 minus 2 times 5 cubed, which is equal to approximately negative 242.55. Now, you think you're finished, but remember, you were given an initial condition. The particle started at 0, 7, so you have to now add 7 to that position, and you end up with negative 235.55 approximately. So there is our first question finished with position of our particle. Second question, at the same x equals 5, what is the acceleration of the particle? Well, if position and velocity are original function and first derivative, acceleration is equal to f double prime, or the second derivative of x. So what do we have to do? Take the derivative of our x to the 1/2 minus 6x squared. And so our derivative techniques subtract 1. So we have, or what we do is we subtract 1 from the exponent and then take the exponent and move it out in front. We have 1/2 x to the negative 1/2 minus 12x. This right here, 1/2 x to the negative 1/2, can be rewritten as 1 over the square root of x minus 12x. And so now, again, we have our x equals 5. We plug in 5 to our problem here, and 12 times 5, which is equal to 60. And we have approximately negative 59.55, whatever your unit per whatever time, and then squared is usually how acceleration is written, like gravity is written as meters per second squared. Is the original function concave up or concave down at x equals 5? Okay, concavity. If you remember the PowerPoint, concavity deals with f double prime of x, and it's very simple. If your second derivative is negative at a certain point, we are going to have a concave down function. So because x at 5 is equal to negative 59.55, we know that the original function is going to be concave down. And really, it's as simple as that. So thank you for listening, thank you for paying attention, and hopefully now you will be able to excel and exceed in whatever particle motion questions you have on your AP exam.